Using that area model, what's the probability of getting two heads? 1 out of 4. How'd you get that, Sabrina? Okay, so heads and heads overlap at one spot, right? Okay, now I saw some people doing this yesterday, and I don't think it's a bad idea. They were filling in their area models as if they were Punnett squares. Okay, so like they're writing like heads, 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 tails, tails, heads, tails, tails, like that. And that helps them see how many outcomes are heads, heads. Right? And now we've turned our area model into a sample space. Okay? Alright, so we turn our area model into a sample space. Got a question, David? Okay. So there's only one heads, heads out of 4, right? So the probability of getting two heads is 1 out of 4. Now what's the probability of not getting two heads? 3 out of 4. Why? Okay, because there's 3 boxes that don't have two heads in them, right? Now, what's a different way besides using the area model to find not two heads? What should my probability for two heads and not two heads always add to?
4.
1. 4 out of 4, right? So, in order to find not two heads, we could do 1 minus the probability of two heads, right? Which is essentially 1 minus 1/4, which equals 3/4. Right? So anytime you have the probability of one outcome, to figure out the probability of not getting the outcome, Brady, you just got to subtract that from 1. Does that make sense? Does that make sense? Okay. We're going to need the probability of two heads and not two heads for the rest of class today. Now, I have 5 questions on the board that we're going to answer. All right? They kind of play off of things we already know, off our and statements, our or statements, and our not statements. So hopefully remember those, what each of those means. All right. What is the probability it takes 2 tries to flip 2 heads? So if I have 2 coins, here I have a quarter and a penny. What this is asking is if I flip my penny and I flip my quarter, what's the probability it takes me 2 times of flipping them both to get 2 heads? Okay? Think you know already, Mark?
I'm guessing.
You're guessing? Okay, what's your guess?
160.
We'll get there. Okay, I don't think you're right.
Yes.
We'll get there. I'm glad you guessed, though. So Mark's guess is 1/16. Hey, it's worth a guess. All right? Now, if I'm going to figure out this probability, we need to take that statement, we need to dissect it to figure out what events are happening here and what kind of statement is causing this. All right? Basically, what has to happen on the first flip, what has to happen on the second flip, and then what kind of conjunction joins it. Is it and, is it or? Okay, so if it takes me 2 flips to get heads, that means what did I get on my first flip? If it takes me 2 flips to get 2 heads, what did I get on my first flip? I could have got 2 tails, right? Could I have got a heads and a tail? Yeah. Could I have got a tail and a heads? So it's everything except what? 2 heads. So what this means is that on my first flip, what we're trying to find here is we're trying to find the probability that on our first flip, we didn't get 2 heads, right? That's on, not or. Okay. So we're trying to find the probability we got not 2 heads on the first flip, right? Right? Then what happens on the second flip? We get 2 heads. Right? Now what conjunction is going to be between those? And or? What do you guys think? And. Okay. It is an and statement. In order for it to take 2 flips or 2 tries of flipping 2 coins to get 2 heads, it has to be an and statement. Okay? It means I didn't get 2 heads on the first flip, and we got 2 heads on the second flip. Okay. Does that make sense? Yeah. Okay. Now, in this probability notation, this right here, guys, this is what we call probability notation. So on the worksheet, we're going to get involving this. I'm going to ask for probability notation. That's what I want you to do. I want you to take the statement or the question they're giving you, and I want you to dissect it so you can identify the events and the conjunctions. Okay? So, which of what I've written here are the events? Okay? Not two heads, right? On the first flip, that's one event, isn't it? Right? What's the second event? Two heads on the second flip. So, this is our first event. Two heads on the second flip is our second event. Right? Does that make sense? What's the conjunction? And. Right? What does and mean? Okay, good. And means multiply if what? If what?
Independent.
If what's independent?
The events are independent.
Good. Multiply if the events are independent. So, here's the question. Is my first set of flips independent from my second set? So, let's think about it this way. If I flip my quarter, and I flip my penny, okay? Oh, I got two heads. Kind of funny. If I flip my quarter and my penny, all right, does what I got on my first flip affect what I get on my second flip? No. So are they independent? Yes, they are independent. So since these are independent, this statement becomes the probability of not two heads, good? Good, times the probability of two heads. So since the events are independent, we can rewrite our probability notation in a much simpler form. Right? Would you guys agree this is a little more simple? Yeah? Now, this is where our area model from before comes in handy. Okay? What was the probability of getting two heads when I flipped two coins? 1/4. Right? We got that over here. What's the probability of not getting two heads when I flip two coins? 3/4. So I know these probabilities, don't I? So we can figure out what's the probability it takes two flips to get two heads. So for not two heads, we write 3/4. For two heads, we write 1/4. Now we can multiply fractions. 3 times 1 is 3. 4 times 4 is 16. Multiply, not add. Okay. So the probability it takes two flips of two coins to get two heads is 3 out of 16. You were close. Okay. Does that make sense? Are there any questions about why we multiplied, where we got the 1/4, the 3/4? Any questions about that stuff? Any questions? No? Okay. Yes?
What situation do we use or?
We'll get to that. Okay. We'll get there in a second. All right. Any questions? No? All right. Next one. It says, what is the probability it takes 3 flips to get 2 heads? So, I'd like you to take a moment or two, and I'd like you to work on this next one. Okay? What's the probability it takes 3 flips to get 2 heads? Okay? Take a moment, try this one out. All right? Everything that we wrote in black over here, the probability notation, the and statement, the multiplication, and then the fractions, that's what I want to see written for this one. Okay, so everything we wrote in black for the first one, right? Everything we wrote in black for the first one, I want you to write that in black for this one. All right? So it's what is the probability it takes 3 flips to get 2 heads? Everything you did in black for the first one, I want you to do that for this one.
then take fast as soon as it's not look like, oh, don't waste it for today. This is kind of fun.
Josh, okay?
Yep, sounds good. So you don't get two heads on the first two flips, right? You'll get two heads on the last flip. So then how many times do you have to do four?
If you have a question, let me know, please. If you have a question, let me know. Nope, just that first one. If you want to try the second one, if you don't the first one, you want to try the second one, go for it.
So it's probably takes 3 flips with 2 heads, right? So remember I wrote that sentence, not 2 heads on the first flip and 2 heads on the second flip? Okay, so what's the problem with that? What's that with my first flip? Not 2 heads, right? Otherwise I won't flip again. What happens on my second flip? Okay, I want to get 2 heads on both coins. I want to have both coins. I flip 2 coins. First flip, not 2 heads, right? I flip 2 coins, my second flip, what am I going to get? But then I'd stop, wouldn't I? So what is it going to be? Not 2 heads, right? And then we get on the first flip. 2 heads. Right? So we're going to have how many not 2 head statements?
All right, so let's try it. So what's the probability it takes 3 flips to get 2 heads, right? I want you to dissect that. Make a probability notation. All right, so our probability notation for this one is the probability of what? What happens on my first flip? Not 2 heads. Right, that's my first flip. Right? What about my second flip? Not 2 heads again. If I got 2 heads on my second flip, I would stop, wouldn't I? Right? And what's my third flip? Okay. So this is my first flip.
I didn't write first flip.
First flip. This is my second flip. That's my third flip. Right? Are these flips independent of each other? Yeah. So what can I do with all these? Multiplication. Good. Use multiplication rule. So probability of not 2 heads times probability of not 2 heads times the probability of 2 heads. Right? We know from before the probability of not 2 heads is what? 3/4. So it's 3/4 times 3/4 times 1/4. Does that look right? Yeah. What's 3/4 times 3/4 times 1/4? Good. 9/64. Thank you. Nice job, guys. Does that make sense? Yeah, you guys with me? Yeah? Okay, let's try this one. What's the probability it takes 4 flips to get 2 heads? Okay? What's the probability it takes 4 flips to get 2 heads? What? Okay. Try it on your own. If you're done, great. If you've already done that with the next question, try the 2 all the way over on the right. Okay? At least 4 flips to get 2 heads, and 5 or more flips. Okay? Try to think about how at least is different than exactly. Get it?
Pencil's still moving.
All right, for this one, how many not two heads am I gonna get? 3. Just gotta take me 4 flips, right? Okay. So this one is the probability of not 2 heads. Then what? Not 2 heads. And 2 heads. So how many 3/4 am I gonna need? Oh, it takes 4 flips. I did 5. You're gonna tell me, wasn't it, Doug? Okay. So how many times do I have to use 3/4? 3. Right? How many times do I use 1/4? Once. So 3/4 times 3/4 times 3/4 times 1/4. Okay. Does that make sense? No? Yeah? Okay. Now, as you punch that in, I want you to think, what is repeated multiplication? How can I rewrite repeated multiplication? Was it John? Exponents. Okay? So, if you're getting sick of typing all these in, okay, I can take my 3/4 and write it as what? 3/4 to the 3rd power. Okay. So if you're sick of typing them all in, you can put. Make sure you put 3/4 in parentheses, because if you do 3 / 4 × 3, that's going to raise the 4 to the 3rd power, not the 3. Okay. So make sure you put the fraction in parentheses. So 3/4 to the 3rd power times 4. What do you get, Jay?
27.
27 over 256. Does that make sense? Yeah? What do you think about this? Easy? Yeah. We'll throw you a curveball now. Alright? So we've done the one straightforward where we've been doing exactly 2 flips, exactly 3 flips, exactly 4 flips. Alright? The next question says what? At least. Doug, what was that question you asked me earlier? Okay, what situations do we use or? Alright? Now, if it's at least 4 flips, this means we're doing the probability of what? 2 heads on first flip, or 2 heads on second, or 2 heads on third, or 2 heads on fourth. So, when they have an at least problem, usually, if they're nice to you, they'll do it after they've had you calculate the probabilities for 1 flip, 2 flip, 3 flip, and 4 flips, and then we'll do it at least 4. Now, if I'm doing it at least 4, it's an or statement, right? Because at least means you can get 2 heads on the first time, the second time, the third time, or the 4th time. Does that make sense? Yeah? Now, what do or statements do? Are they multiplication or are they addition?
Addition.
They're addition. Good. They're addition. Now, the end of the or statement is a subtraction of an and statement, right? Right? So, the and statement would be 2 heads and 2 heads on the first flip and 2 heads on the second flip. Okay? In this case, we're trying to figure out at least how many flips does it take to get 2 heads. So if I get 2 heads on the first flip, am I going to try again? No. So 2 heads on the first flip and 2 heads on the second flip, are we going to have both of them? We're going to have both of them? No. So those events are mutually exclusive in this case. Okay, when we're talking about at least 4 flips, 2 heads on the first, 2 heads on the second, they're mutually exclusive. Okay? Meaning, do I have to have that minus and statement? No, that minus and statement is 0. All right? So for these ones, when we do the at least, we can take our probability from 1 flip, which was, probability of 2 heads on 1 flip was 1 out of 4. Probability of 2 heads on the second flip, which was Nope. Probably it takes 2 flips, 3/16, plus the probability it takes 3 flips. 9 out of 60. Yes, mutually exclusive means the and is 0, not the or. Okay. So this is probability on 3 flips, plus the probability on 4 flips, which was 27 out of 256. That's why if they're nice to you, they'll have you calculate 1 through 4 first, and then we can add them all up. Right? So now I can add these, and we'll get our probability it takes at least 4 flips. No, it's not. No, we're adding these all. Okay, we're adding 27 out of 256 to 9 out of 64. Okay. Now I would use your calculator to add those because your calculator does common denominators real quick. What'd you get, Sabrina?
175 out of 256.
Okay. So the probability we get a heads, the probability it takes at least 4 flips to get 2 heads is 175 out of 256. Does that make sense? You guys kind of see how we did that? Yeah. Okay. What's the probability it takes 5 or more flips to get 2 heads? Now you're probably thinking, oh, Mr. Branch, it's going to take forever. All right? Because 5 or more means we're going to do 5 flips plus more, right? So 5 flips plus 6 flips plus 7 flips plus 8 flips plus 9 flips. We can do this all the way to when? For as many as I want you to, right? If we're doing 5 or more, it doesn't tell you where to stop, does it? We can do this till I retire. Sounds like fun, right? I hope that happens after I retire. Okay. But we can do this for the rest of the school year, right? And we still wouldn't be done, would we? Now, 5 or more flips plus at least 4 flips should add to what when we're talking about probabilities? So the probabilities of 5 or more plus the probability of at least 4 should add to what? Should add to 1, right? Because the overall probability of all the possible outcomes happening is 1, right? So my answer here and my answer here should add to 1, right? So that means the probability it takes 5 plus, that's 5 or more flips, is essentially the probability of not at least 4 flips, right? And we remember that not means what? What does not mean? Means what minus? Means 1 minus the probability of at least 4 flips. Okay? 1 minus the probability of at least 4 flips, right? 4 flips is 175 over 256, wasn't it? So 1 minus 175 over 256 will give me the probability of 5 or more flips. It is a shortcut. How do I get 1 again? Because the probability of at least 4 plus the probability of 5 or more will be what? Will be 1, right? Because these are all the possible outcomes, aren't they? Right? And the probability of all the possible outcomes is 1. Okay? Does that make sense? Okay. So it's a very, very, very shortcut. Rather than taking till the end of the school year, all right, we can do this in 30 seconds. Right. So 1 minus 175 over 256. Trey, you get it?
Yeah.
What is it?
Oh no, I said it.
Okay. It is 81 over 256. So the probability it takes at least 5 flips, or sorry, probably it takes more than 5 flips or more, is 81 over 256. All right, does that make sense?
Yeah.
Okay. I'm going to add 1 question to the board, and I think, Mr. Branch, we did enough already, right? Who's thinking that? Who's thinking we did enough already? Okay. Trey, I want to add 1 question, okay? Because all of these that we've done have been how long till we get something, right? How long till we get something? Well, some games like Monopoly, all right, you have an event that repeats. right? Like in Monopoly, if you roll doubles 2 times or 3 times, you go to jail, right? Right? There's a probability there. Okay? So, last question, then we'll be done. What is the probability we flip 2 heads 3 times in a row? Okay. What is the probability we flip 2 heads 3 times in a row? Let's dissect this statement real quick. 2 heads 3 times in a row. That means what did I get on my first flip? 2 heads. What about my second flip? What my third? 2 heads. It's an and statement again, isn't it? So it's the probability of 2 heads and 2 heads and 2 heads, right? Right?
Yeah.
Are these events independent? Yes, right? The flips don't affect each other, do they? So we can do the probability of 2 heads times the probability of 2 heads times the probability of 2 heads, which is 1 out of 4 times 1 out of 4 times 1 out of 4, which equals 1 out of 64. So this consecutive probability stuff is kind of cool, I think. Right? A lot of board games use the ideas of consecutive probability, Monopoly especially. Right? Rolling doubles 3 times in a row is 1 out of 6 times 1 out of 6 times 1 out of 6, or 1 out of, is that 256? No, it's not. It is 180 plus 36, 216. Okay? 1 out of 216. Okay? So, I think that's kind of cool. All right. Any questions about this consecutive probability stuff? Anybody?